I invite our chairperson, Dr. A. Murugadas, head in charge of Department of Inorganic Chemistry, University of Madras, Chennai, for the introduction of guest speaker.
One second.
Yeah, thank you. So it's a very pleasure, Saravanan, who is presently working as an associate professor in Department of Environmental Science and Engineering. That means ISM, that's the Indian Institute of Technology from Indian Institute of ISM Dhanbad in Jharkhand. So Dr. Saravanan has a vast of research experience and so many great accomplishments towards his research. I know very well, and is a great person in this, especially in the light driven nanomaterial, who is constantly working on this field. So to start first, and Dr. Saravanan has completed his BTech in University of Madras, and then MTech in VIT, Villupuram Institute of Technology in Vellore. And then after that, he successfully completed an MTech, and then he entered into PhD program in IIT Guwahati, where I met Dr. Saravanan. So, and then he completed PhD, and then he went for, he got so many opportunity and so many position. For example, in abroad, he worked, and initially he got the assistant professor, senior lecturer in Amrita University, and then he moved in 2008 to as assistant professor in National Institute of Technology, Tiruchirappalli. Again, he's a senior lecturer he acted, and then he joined 2016 as an associate professor in Indian Institute of Technology, that is called ISM, where he presently is working. So in addition to that, he has so many research accomplishments, and with so many awards, more than 24 pages are there. And also he has so many, the average impact factor is a great publication he is having, especially towards the research field in nanomaterial, which has light harvesting material for the water remediation purpose. And he has so much enormous contributed towards that research. He has 98 publication with average impact factor around 4 to 5. And also he has so many projects. He already gone more than 1 crore like that project. And he also has very many international awards and national awards. And so now I request Professor Saravanan to take a session and give the deliver the lecture. Thank you.
Nanomaterials, a leap from laboratory real-life applications. So my talk will be focusing mostly on the prototype development as engineering aspect. I don't touch on the chemistry or material chemistry. Many eminent faculties are the researchers who already presented or about to present on that aspect. Though my study is also insight of studying the material chemistry only. If you have gone through all my papers, I have never touched on the environment aspect itself. Completely my study will be on insights of material chemistry, mobility of electrons, physical chemistry, interactions, heterojunction formations, everything as like a physical chemistry only I used to work. But actually we are working on a project, an imprint project, where we are about to develop a prototype of say 30 to 40 liters of water purification, that is solar water purifier, in order to serve the local community of our nation. So that is our task assigned to us, and in which we are working on it. So I'm just going to just explain the journey. So how I end up with that one. So what has been contributed and why there is a bottleneck. What is the bottleneck in the aspect of engineering, what are in the aspect of materials also. So that whatever we faced, in a prototype development, actually commercialization and any aspects. So that's what I'm going to share. So to know about the importance of water, it's well known. So we cannot talk a lot about all that. It means a simple thing which a Tirukkural states what is the importance of water. So everyone knows it because most of them are coming from a Tamil community background. It is also having English translation also, but it's a scared bit. So near-indri ammayada ulaghu yaar yarkum vaanindri ammayada ulaghu. Very simple. And he also defined it is an ambrosial food. It is like amalgam. It is ambrosial food which is for longevity. Very important point to be noted. This is ambrosial food and longevity. It's a very important point because this is what we are not talking about some herbal things. It is a water only. A water which is having some nutrients. So that is what we are going to talk about. So that itself a very important thing. So this importance was felt by the ancient community who lived either in India, either in a Babylon civilization or in Anatolian civilization, whatever it can be. But they felt the importance of the water. all the civilization, wherever is that, the cradle of civilization is a river. Very important to be noted. History is always important in the aspect of science and technology, not for learning purpose. It is in the aspect of science and technology why it is very, very strong. They already settlement will take place only in the river. So water is a very basic need, that is a drinking water. And they also had a systematic water purification systems. Lots of archaeological evidences has shown to us that Indus Valley civilization, which belonged to 3000 to 4000 BC itself, had an water a perfect water purification system. So this is not to even. I will tell you a simple thing. Our Tamil community is actually they call Kadalodigal. They are actually naval community where they used to travel widely for the purpose of business. They are sailors. So during the sailing purposes itself, you want to have enormous amount of water which you cannot carry over there in your ship, which will increase your payload. So they don't carry much on that. So what they take mostly on the foods alone, the water, whatever they go in for, they had a treatment technology on the time, which is actually not properly documented. One of the things what they use it for, that you will take the drumstick seed, that moringa seed, they use it for treatment purposes. They do desalination itself at the time by using during the travel itself, voyage, they used to convert everything over that, their separation process, and they were using it. But nothing is documented in a proper manner. Only 20% or 30% are there. I mean, the researchers like Orissa Balu, they are working on that aspects actually. They are on that. But it still stands because it is there existing over there. So now the problem is that we currently talk about sustainability currently. The sustainability is nothing new. When UN come up with something else, it's nothing new. The sustainability is existing for 3,000, 4,000 years, or when the human evolution started itself, sustainability started. It is nothing to new to talk about. It's not a new topic which started 20 years before, 3 decades before. No, it started day one itself. Now it becomes very important. That's the difference. Need is there, important is there. At the time, the need was not that much because fully nature, 100% nature was there. When the ratio between the nature is reducing, then we will fight about the sustainability, because we want to produce everything. When population is exploding, you need the demand is there, and there is going to be high demand. Where is the supply? In a basic economy point of view, you need to create them. You cannot produce them, you are creating them. Production is different, creating is different. Creating is artificial, production is natural. Yeah? And if you take a paddy which can grow for 90 days, means now you are bringing it to 30 days. Why? In order to meet the need. That's what very important. So that's where I end up with all this problem. I'm just taking one as a food security. That's where I end up with the problem. Using fertilizers, using actually urea, all chemical derived. Nothing is derived from the organic things. So what happened? It has completely contaminated. Only 3 environment. Whenever you talk about even environment engineering also, the 3 primary pillars in environment engineering itself: water, air, that is it, and solid. These things, because this is very natural metabolic waste which we also generate. We just exhale CO2, we also urinate, and we also have the stool which is coming over there. So this is a natural system. It's a mass balance. As a chemical engineering or environment engineering, it's a mass balance. So nobody can keep away from this one. So when this is going to happen, this is applicable to any industries also. 100% you are taking 100 kg when you do a stoichiometry. 100 kg product is not going to be produced. 20 to 30% is going to be anything. Some is accumulated, some is coming as a byproduct, some is a waste. This waste are completely entering into the environment and they are killing that environment. When 100 years before or 200 before, the industrialization was not much. So there was much issue. So when last 75 years after the Second World War only, the rapid industrialization, which you cannot imagine, has started because of many things. So everything came over there. Industries has gone, pharma, every industry is pesticide, everything has started. So completely come. Now after 10 years before, UN has a wing has started this food security, energy security, water security, health security. Why? We have completely contaminated everything, whatever is available. Now we are actually in alarming rate. Now we want to talk about this one, climate change, everything is coming, which is on the aspect of air pollution. Because I am an expert in air pollution also, not in the aspect of research, in the aspect of teaching, which I used to do it for more than 12 years. In terms of climate change also, I used to teach. I teach in terms of control. I used to teach as a basic atmospheric chemistry, that is air chemistry also I used to teach. So we used to have a strong background from there. So what happens? Completely everything is gone. Once everything is gone, it's very difficult. Air, the problem is that you cannot recover back. At least water, it is a regional or is specified one. It's like a tumbler, you have a water, in a glass of water. It can be avoidable. You can avoid it. and you can treat it also. But air, you don't have that scope itself. Air has to done in situ process. So it is going to be much challenging when it comes to air. I'm not touching that point, but we are taking only air into this one. So air, water is related to health. Water is related to health. Air you inhale is related to health. What is related to security? Everything is related. All are interdependence. We cannot say separately. All are not separate. They are interdependence. So that's where the problem starts. So when they are going to start about these sustainable, all these problems, all are interrelated. When it comes to interrelated, poverty also related to food security. Again, it is related to water. It is related to energy. It is related to education, economy. Everything comes over there. So it goes in that aspect itself. Even it makes in the gender equality also. I mean, giving a simple example. Why? If you take, when we had a good experience when we competed, when we actually went for a European Union project. Project is not successful. Professor Gopinath was also was there in the team actually as a main person. Though it was not successful, we learned a lesson from that. What we learned, we need to develop a business model when you want to go for the European Union 22 H20 project. When we are doing a lot of background study with NGO and other things, what we learned was many of the villages in India, their girls, they cannot go to school mainly because to fetch the water for their daily needs for 10 kilometers or 15 kilometers, in which girl child are given over there. Keep it that way. Why this gender equity is very important. Keep that in very important point. That's why it comes over there. Not only here, even in actually African countries, third world countries, they go for that and take the water. So per day, their life is gone only bringing water alone. So they never has a proper education. Nothing is there. So what happened over here? Their life is ruined. Almost it is ruined. They don't know anything. Their life is actually systematic. Get in the morning, go there, come over there. So it becomes a big issue. It's a chain reaction like MLM. It is a chain reaction. It goes in that aspect. So what happens now? The water security becomes very important. Why? Then availability of natural resources itself, water itself very less, because we almost deployed completely the groundwater also. It is underground water also. So the resources is mainly groundwater, surface water. The surface water, the problem is going to over there is actually, there is a difference is that groundwater and surface water, the chemical characteristics, physical characteristics, biological characteristics are completely different. When you go for a surface water, you will have only contaminations mainly because of your runoff. Runoff is coming over there from industries, agriculture activity, or anything. Suppose you take a dam as an example. I'm just taking a dam as an example, which is located in the Western Ghats. My example is in Western Ghats. I'm taking one thing. You have 2 to 3 dams in Western Ghats. That is, one is close to that. That is for the Papanasam Dam. Upper project, 2 projects are available. They are good dam which is used for drinking water purposes. First used for hydroelectricity also, because I know that condition very well. So when they go for the catchment area, what is happening to the catchment area? They are having full of forest cover, which is commonly completely dominated by the animals. When it is coming by wildlife over into the species, completely your runoff will have the wastewater is going to be natural organic matter, fecal contaminations, all those things come into the picture. Same when the runoff takes place in agriculture activity, which is close to the land. I'm just coming back to the mountain, to the land. Okay, so when you do the agricultural land purposes, your runoff is mainly because of pesticides, and then it is going to be what are all the things you are used for your agriculture activity. Everything is going to be washed away. Your topsoil is also going to be washed away. So what is the maximum present in the topsoil? Your urea is present, your pesticide is present, apart from the nutrients, okay, natural nutrients. So they are going to present in a bigger contribution level. So their concentration keep on increasing because it's a recurring process. It's a recurring process. It goes over it goes to the local lake, or it goes to the local what you call pond, and then you can just contact it. So concentration keep on increasing over there. So what happens, though it is a seasonal, that specific seasonal one, it's not perennial at that specific seasonal one, but in dam it is a perennial accumulation can take place over there. Okay, so that's the problem. So some of the water which is going over there, they are completely treated. 50% is treated because your porous bedrock itself act as a filter medium. So contaminant transportation, during the transportation process itself, some of the things is going to get treated. So only thing is that your groundwater is going to get rich in total dissolved solids. You will not have this kind of what I am talking about, those runoff related matter. The issue is with the persistent organic pollutant, which is heavily found in the food chain, in water chain, in all the aspect, which is going to cause us. Slowly they are poisoning. Okay, so I'm not taking in the other aspect. We are taking only as a one pillar, which is the water. So what is going to happen? Percent over there in the water, they are going to create, they are the killer, and they are going to kill the future also, not only the present and the past, present, future, everything is going to be there. It includes that mostly the pharmaceutical is also coming to the pictures, where you have estrogens and antibiotics, everything is coming over that, because whatever we actually consume, we are going to urinate it, so that is also actually discharged in the urine itself. So this is wastewater contamination. When this is going to have a sewage wastewater, which is having a high level of this, the pharmaceutical waste itself present over there, that is going to interact with the water system, and that is going to create a problem. So that is what untreated. You can see this untreated sewage. They are also going to cause a lot of problem, because mostly if you see in India, all the city is not having a proper water treatment system or sewage wastewater treatment system. They are having lots of problem. If you just go to a foreign nation, like anywhere, you just go to Germany or go to a foreign country, you can just take the tap water directly, you can drink it. You don't need to add any additional water treatment system. Is not necessary. Purification is necessary. Even in Singapore, in Malaysia, it is necessary because of that the system. They do a water treatment, because I am well versed with the Malaysian system. I used to work with them also, water treatment aspect. The problem is that they have the contamination during only the transportation and storage, not in that purpose. That is why they used to have one few basic filtration system is only needed for them, because that pipes they are using little bit of iron will corrode over there, so that will bring over there. Other than that, there won't be any problem with the things. You can directly tap the water, you can bring it over there. No suspended solids will be there, so no unwanted. That is, it meets the WHO or BAS standard, whatever we are just talking about, or EPA standards, so there won't be any problem. But here we are not getting water from there. We need to spend at least how much from your own pocket for the daily water per liter. We need to spend from there. Either you buy it from outside or you have your own treatment plant. That's what it is going to happen over there. But this is not a solution. Again, we are dragging ourselves into the problem. All 90% or 95, 100% close to that, all the purification system what we are using currently is going to use RO at the end. You can have 4 stage, 5 stage, 6 stage, 8 stage, whatever the stage it can be. All the stages are mainly for using one for actually used for the suspended particles, which is a 5 micron filters. You can have 1 or 2. The second stage comes with the adsorption by using an activated carbon, mostly derived from the bamboo charcoal. Bamboo. Okay, so that is going to be used. The third one is going to be used is going to be your UV. So UV is mainly used for the disinfection purpose. Ozone can be also used over there, because in order to avoid the chlorine, which is going to cause the carcinogenic. So now the fourth one, which is going to be the main thing, is going to be your key is going to be your membrane, which is going to completely remove all the micro minerals present over there. Or whether it is necessary or not necessary, that is different, because your kidney is selective adsorption, that is selective separation. It is not going to separate everything from over there. Then you cannot survive. Then it is, you are having a problem with your kidney. Okay, it has to absorb back all the necessary nutrients like calcium, which is needed for the bone. If that is also released in the kidney, then that is a disease. Actually, I forgot the name medically. What is the name they call it? Your bone becomes things, and bone structure loses structure because loss of kidney and loss of calcium and the potassium. But here everything is going to be taken over. Everything is taken. It is just a separation process. No, you just use a molecular sieve. Your molecular sieve cutoff is the MWO sieve cutoff is going to be the molecular weight cutoff. You just allows only water alone. It is not going to allow thing. Maybe 5% it is going to allow a little bit, because 100% ideally nothing is going to work as a ideal. It's a real thing. So there is a possibility of little bit thing. But the problem is that 95 to 80% of the rejection will take place. Suppose you take 100 liter of seawater for desalination, you will get only 10 liter. Rest of the 80 liter is or 90 liter is going to be reject, which is a concentrated pollutant. Keep in mind, concentrated pollutant. These concentrated pollutant, whatever you are discharging in your home, in one more pipe is a reject pipe, is nothing but that is also going into the sewage. That is also going to the sewer only or somewhere else. It is entering into the environment. I'm talking about a single home. If you are using it actually at 10 100 millions of community is going to use it work, they become very, 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 very significant. So this solution is not a sustainable solution. It is unrealistic consequences. So this is going to create a lot of problem into the environment. What is that more reliable, sustainable solution for that one? That is what the question comes over there. So the sustainable holistic approach is going to be by using the light-driven photocatalysis, light-driven energy materials. The light-driven energy materials are very familiar because they are still used in a solar cells also. We are using in solar cells. Concept is same, the functionality is same, everything is same. The only difference is that when it comes to the scale up for the water treatment, there are certain protocols are there in order to look into over there. Whenever it comes into that the protocol of solar cells, you need to look into the different protocol. When you are going to work for that CO2 reduction or methane reduction, whatever it can be, water split reaction, the protocol is different. So based on that application, things will change actually. You need to do some kind of modification has to take over there. Whenever you make a movie over there, no, you cannot directly make a movie for Tamil. When it is made in Tamil, when you want to do it for Hindi, then you have to do it accordingly for the Hindi culture. Changes has to be done. So the ground is different, science is different. So accordingly, things has to be done over there. So when it comes over there, it is well known. There are going to be photo approaches. You can use it for any purposes, like what do you call water splitting, whatever it can be. Something is not listed over there also. CO2 reduction, CH4, water split reaction, many things is there. It can do over there. So the problem comes over here that it has a wide back of history from starting from even 1911 itself. But the thing is that starting from 1911 until this Fukushima, whatever the group has broken, and for taking forward from the Fukushima group until now, there was not much marvelous thing has been done. Why? You see, this much of paper is published until 2018. You see, 8,000, 9,000 paper is published, which I'm talking about having a keyword as a TiO2 photocatalyst, light harvesting, energy storage material, and NIR activated photocatalyst as and keywords. I'm talking about full solar spectrum. But if you see in terms of technological readiness, your technological readiness is available only for the solar cells. The technological readiness goes in this way. It starts with the idea, it goes with basic research, it moves into technological formulation, needs validation, small scale prototype, large scale prototype, then prototype system, demonstration system, first commercial system, full scale commercial system. You have seen the steps over there. How much steps? 9 steps. So jumping from here is going to be a big problem. But for energy application, these steps has been reached to the full commercial scale. We are having a torchlight or anything, even made it out of Chinese company, whatever the company it can be, but it is made out of solar cells. All our solar cells are available. It came into that, 50 rupees it is available solar cells. But when come into the compare the same in a background of water purification, still in a small scale prototype, it has not reached the thing. See, still it has to reach the 9th step, which has in a 4. You need a very high energy for that one. You cannot jump directly from 4 to 9 because thermodynamically is a problematic. We need to go step by step only. But this step itself going to be a challenging. So see over there, artistic illustration which is given over there in a different way for the audience to understand. You start from the seed, it is yielding an apple. It takes 50 years. I'm talking about the technological readiness. So now you are having a farm which is gigawatt, which is gigawatts. Now the same, I'm applying for the same material using for water application. Only thing is that it is ROS going to be generated over here. The difference is that you're going to harvest that electron generated over there by separating the H plus in the solar cells. Here you are going to use this charge carriers for the secondary reaction, which is going to get the ROS. And these ROSs in different forms is going to help you in that they are going to interact with that pollutant present over there, or even that viruses, whatever it can be, completely it is going to purify your systems. So this is what it is happening. But still, the thing is that it is also in the aspect of we have. What I have shown are some of the models which has been studied by them. Even if you just go to a prominent researcher group in Spain, Plataforma Solar de Almeria, which is a Spanish name. They are working for more than 30 years, Sixto Malato and many professors who are a pioneer in this area. They are doing solar detoxification of this one, of water by using different reactors, cascade reactor, falling film reactor, everything. The one which I am showing over here, what you see is this was carried out by German airspace. German space also. They tried for that by using TiO2 as a photocatalyst. But still, this research publication itself not much. In terms of scale up, in terms of engineering aspect, you don't have that much paper is published. If you get 1 or 2 paper, it's a big deal to publish in a year, because they don't find that much of things. So it stopped in the stage. So that is why we want to carry forward next one. What is the bottlenecks? These are the bottlenecks. As a material, these are the bottlenecks. Material bottlenecks can be broken, no issues. Now, how to scale up this one? That's why it comes over there. There's recombination, reactivity, separation. Many people are working on that, and this group is working to reduce on that for a different aspect. To run even CO2 reduction, which is thermodynamically challenging. Solar fuels. They are all very thermodynamically challenged to convert the CO2 to H2O to react it to form the valuable products. But still, people are working and they're coming with the very vibrant materials which can work, which can contribute for that one, which can break the ice, and then they can go over there. So this is some of the materials has been tried for this purposes also. So most of the studies which I am going to show over there, I'm not going to touch up the material aspect as I said. I'm just going to present only in terms of your scale up aspect alone. Okay. So we also had that everyone has a destination. If I'm starting my research right now, I have a destination for my research. I cannot do a research and arbitrarily. Okay, put that one. Okay, we do this area. Okay, we do that. No, it has a very straight, perfect destination. The destination is that come up with an commercial product, possibly. That is what the aim. So for that aim only, my arrow is moving in the directions. I want to hit that arrow. My arrow is that target is over there. I'm just throwing my arrow in the trap. So my arrows these are my arrows, which is going to have a different material. First we will develop. So we will understand what is the problem. For that we need to develop aspects of the chemistry. Okay, it's a work functions, everything, electronic properties, everything we need to understand. Interaction of the two materials, heterojunction formation, whatever it can be. So we have tried finally for water treatment. The ultimate happens in the materials, I don't bother. My aim is I want to have a quick quick, very fast remediation. Any compound has to be treated in a short period of time by using a solar radiation, and it must have an ability to reuse for 2 to 3 cycles, 4 cycles, economical point of view, engineering economics point of view, so that viability, commercial viability will enhance that aspect. If you see over the TiO2 GO SR4 material, that has that ability where it can treat it very fast. That is, in 180 hours, it is going to treat 2,4-dichlorophenol, which is a complicated chlorinated compounds. Because most of them are chemistry, you know about the complexity of dichlorophenol. Breaking down is not so easy, which is not easy. Confirmatory test like your GCM, LCMS or TOCMS is also done. I'm not presenting over that. Okay, to do the time limitation. So same aspect we tried with NiO. A different aspect, because here we are talking about the material as a spherical materials. This is a nanotubes. Nanotubes, there are few advantages, because when we went for that separation aspect, when it is a magnetic material, it can be separated easily from the waste stream. Then also there will be a carryover will be there. 100% all are not going to be recovered. So what we thought, this is also having a little bit of problem. So why can't we go with the nanotubes? So in the nanotubes, we can have a in a substrate, we can have a nanotubes. Then that can be shaded over the material easily, so that like a deposition can be done, so that can be sustained. That deposition can sustain for a long period of time. There won't be runoff, erosion will not be there. So we tried. So at that point, what we tried was NiO, the TNT. Probably that material was wrong. What we had chosen was wrong. So that's why it never ended with a proper result. It means in terms of application, everything is not done so quite an interesting material. So we just went with a different. We studied many other materials. So we went with, why not we do with the rod shapes and see over there. So that rod shape also, we went with the titanium dioxide, the TiO2. So the TiO2 also had a very good, we know, but this was studied for the in the presence of sunlight only. Okay, not in the other aspects, nanorods. So you can see over there, it is having a very good ability. Here we used only dye. The reason is that there are few technical infrastructure facilities also hurdles we are facing. Mostly I used to study only on the persistent organic pollutant. That was my objective. But when time drags me, I cannot do on that area because of the lack of facility. Because most of the study I worked in Malaysia, I don't have any problem over that. But in here, I'm facing 30 to 30% of the facility over here, which is I'm not having. So we need to force to go for dye because of that situation. No other possibility for us. Okay. So sometimes when we have it, we do it for the bisphenol A. We always take as a bisphenol A. So there is one more, is that the C dots, which is derived from the organic. This is from natural materials, which does not has any problem over that. When toxicity and other comes into the pictures, I'm talking about that one. Very simple aspect. We have not gone through that much deep as of now. Okay, we have carried out few toxic studies also. We have never seen any leaching of materials is taking place over there. That has been already confirmed. We are having over the data, everything over the LCMS and other things are there. No leaching is taking place over there, even after 30 days of 30 days of actually sinking over the materials over there. But normally say 30 days we don't sink the materials over there, because water treatment takes place in 3 to 4 hours only. You need a water in 3 hours, 2 hours for the per day for cooking and other aspects. So the maximum time interaction time water is going to be maximum 5 to 6 hours only, or 1 day. So it is obvious it is not going to happen. So C dot is also having a very good ability over there. So finally, and second thing, we went with an AG, because AG is going to have a very good RPD, which is going to be a noble metal, which have a plasmonic property, bringing all those things into compound in order to increase the harvesting ability, in order to reduce the treatment time. All these times are normally done in order to reduce the treatment time only. When you are having a more quantum production of ROS, then it having a more amount of charge carriers, more amount of ROS is going to produce, and either it can be OH or it can be anything. That depends upon the domination. That is going to help you for the redox reactions, and then your treatment is going to be quite fast. That is what the aim over here. So we tried with the conducting carbon, that is GO, and AG and TNT nanotubes also. So that also had a very good ability in treating the over there in 2CP. So, but when everywhere what we have tried over there, either GO, RGO, TI2 only. So all the way we want to move over into other aspect. Here also we tried with RGO only, where we used for bisphenol A. We can see over after dark reactions, okay, there is a good absorption is there. It is very clearly seen. It is mainly because of your RGO, which is having a very good surface area. So that is going to help you over there. But all this absorption during the photocatalysis process when it starts over there. Okay, but these are all ternary materials or binary materials. It's not having a single, it's not a single material. Okay, so what happens, this has attracted much over there in AIP, many research blogs and research magazines have attracted, and they have published in many places. So there we started some idea. Why not we move away with this idea? Okay, to for a good water treatment application purposes. So then from there we started everything over there, where we from there, and then we just went with the graphitic carbon. So graphite carbon is a very good one. So production is very easy. Very importantly, you can produce in a mass scale by using only pyrolysis method, by using only muffled furnace. So we did with this GC3 and 4. So we tried to work with GC3 and 4. And we found and marvelous, okay, this is very good. And it's also having a very good ability over that. So with understanding its functionality, chemistry has been done, and its water applicability is also completely understood. So then we went with only GC3 and 4 alone, by just altering it alone. No need of any combinations. Let's see what happens. You see over the dark experiments over the pure and little bit treated over there, as there is self-treated, little bit acidic. You can see self-treated with over there is self-acidic treatment is improving over there. So you're having a very good efficiency GC3 and 4, because the band gap is 2.6 to 2.8, it vary. So it is having a very good ability, but the fast recombination will be there in spite, but the treatment is going to be very fast, that removal rate. So to overcome that one, we came up with an symbiotic interaction, mutual interaction, so that we came up with the plasma perovskite materials, SRTiO3. So then with GC3 and 4. So the combination of this bringing over that, it has a very good ability. You see over the 0 to 24 hours, no absorption takes place. You start from your 24 hours to 26th hour, a fast is going to take place. It's very fast. So GC3A4 ideally is very good as compared than the TiO2. That is what it comes. TiO2 is also having a leaching and problem also that, but GC3N4 is having carbon and nitrogen. It is not going, it's a melamine structure. It is not going to have any toxicity over, the issue is not coming over that. So carbon based material. So that's where we understood. So there we stopped. Why can't we move with the next smart materials? So we went with the smart materials is nothing but MOF. So few MOF like cadmium intercalated CD, MOF, AG, CD, AG intercalated, Fe intercalated, zinc intercalated was studied for the purpose of research alone. Whether it has any background, it can be used or not. When you use, then only we will come to know. It's just a basic research. Laboratory study was carried out, and it was also found to be good. Even in terms of structural stability is also very good. They can withstand up to 400 degrees also. It can be also, I don't have any problem. The linkers and everything. There is no leaching also has been studied. It is also not leaching over there. It is also shown very good. We have used two linker also, bilinker strategy also operate, which is by using for 2-chloro.
Hello, sir. Saravanan, sir. It's not audible to us.
Saravanan, are you there? Maybe net issue.
So is that fine?
Yeah, now it's fine.
Okay, fine. So in that background, locally, everything was tested over there, experimented over there. Even it is going to be AG decorated. So how much time I am left with? So Chairman, can you please just so that I will just present accordingly. I should not exceed my time.
So you can take the 10 more minutes.
Okay. 10 more minutes, sir.
10 more. Okay, thank you. So in that aspect only it was done actually. So we have tried with the AG decorated BiCO4, but purely I'm telling over there, we never tried this material for water application purposes in that context. In that destination, we have tried in the destination of developing a novel smart material and understanding the fundamental science of the material only we studied. So we studied DFT. If you just go through the papers in detail, you can go to the DFT, molecular simulations, everything will be there completely, how it happened, how the material interact, what is the role of AG, what is the role of AgBO3, BO7, what is the heterojunction formation, how the shuttling is taking place over there, what is the time, what is the, what do you call decay time, what is the decay time, what is going to take place, whether it's the PN, that is MIS, that is EAS studies. Okay, impedance spectroscopy studies also will have detailedly be carried out. Marscott keep everything has been studied over there. So thermodynamic aspects also we have studied. What is happening over there also. So, but I'm not presenting all those things here. I'm just presenting in terms of the in water treatment, because our aim is also that if it is good, then we can take it to next level. We are just working on two aspects. If it is work here, it can be used for this aspect. If not, we know the fundamentally what is happening over there. So that's what we have studied. So both the things will be equally given over there. Okay, importance. So if you see over there, the recycles and other aspect, stability aspect, apparent quantum efficiency is also very good for BPA. MO is always good, And BPA is also always good, and it also combined by using a scavenger study, that is by using H2O also it studied to understand the role. So then went with the Z scheme, which is nothing but the GC3N4 and WS2. WS2 is a very good material because that is having a full solar spectrum, which is most commonly used for chemotherapy also. If you just go to the Google type WS2 as a chemotherapy material, you can find a lot of things. It has a wide ability to understand WS2, which is published in 2014, Applied Advanced Materials, where a cracking benchmark paper was published. From there only the idea came over there, and we started from that WS2 also. So WST is also a very good ability over that. Okay, so there where it can have a very good apparent quantum efficiency. Okay, we are not presenting in terms of degradation point of view. We are presenting in terms of more technically in terms of apparent quantum efficiency, where how much quantum is used for the degradation of a TC is actually tetracycline, MB is going to be methylene blue. Okay, even both the things are used for the purposes. So everything was fine. Everything was fine because GC3N4 is our expected materials, and we are just move with only GC3N4. We don't want TiO2 because we have studied more on TiO2 and many reports are available, but TiO2 is also having a problem over there. Coating TiO2 is very easy. When you come in engineering aspect, coating TiO2 itself very easy because I myself have coated TiO2 and we have used for VOC reduction also. I'm not showing here, we have studied in that aspect also. But the problem is that actually coating GC3N4 comes to the picture actually. So that's why we face the problem. So, but though we want to carry over the GC3N4 in the aspect, it has a more ability to treat water very fast, take up sunlight, and second thing is that in terms of toxicity or leaching, nothing is going to take place. Very safe. We can meet after the water which is treated from that, it can meet the BIS standard given by the government of India, WHO standard also. That is what we are expectation. So GC3N4 in terms of WS2 as a co-catalyst that was studied, we have the heterojunction is between GC3N4 WO3, but WS2 plays the different role, not role lambda. Here the role is completely different. So that role is like a Z scheme or S scheme type and type 1 interaction between them. And then these interactions is going to help you for the degradation of all the things, because these interactions is going to help you over that, and they are going to finally generate the charge carriers, and then how much charge carriers is finally left over there in the quantum, actually the recombinations is very low. Okay, in terms of decay time is increasing. Then what is going to happen? They are having available for the reaction to take place over. And then that has been studied for the purposes, and we have seen that sunlight within 60 hours, minutes. I'm talking, no, sorry, minutes. These things gets very fast. In few cases, I said we had a problem. That's why we went with the MO because of that failure of some of the instrument in the campus. Okay, because the bisphenol A and all, we need to have a LC and we need to have a JC. On off, there is a failure happens. So immediately spectrophotor is the only easiest tool you can do it for the study, because we cannot wait for the PhD student. Their graduation is also important. Okay, so that is also focused that. So I said on a thermodynamics point of view also studied over there. And then this is an apparent quantum efficiency with respect to the specific length basis: 300, 500, 700, 980. The whole full solar spectrum, which wavelength is heavily used by them. So WOCN is used. You can see over there. Okay. The WOCN, which is a full solar spectrum, is utilizing even 300, 500, 700, 980, all the wavelength. That is nothing but we call it as a full solar spectrum photocatalyst. So that is what the aim, full solar spectrum. So here what we are just going to the last piece of work I'm just explaining is that this is also done in a different aspect, but we have not studied one for that. It's completely studied in a different aspect, but we have seen its ability to treat the water, because ultimately this was projected as a materials paper only, not with application, only with materials paper. S-scheme ternary photo heterostructure, which is about to publish in Applied Materials today. I think if someone is interested can go through that one, because this is completely thermodynamic point of view we have discussed over that. We have never entered into the pure materials paper, but still for our purposes we tried to know about that reaction and everything, because as an environmental we want to know about. So the apparent also found to be very good. What is happening inside the interactions of what is the role of 2D, how the AgVO3 VO4 interacting, how this GC3N4 is contributing, all those things and all the lovable material chemistry is discussed over there one thing. Very basic point of everything is explained over there. So at last we went with again the started what we said. Previous magnetic materials, whatever we tried, does not has heterojunction. So we tried with a magnetic material creating heterojunction with combined magnetic recovery. So that can helpful. It's just a strategy approach. So that also works very well, where we are having a very good ability to treat the water. You can see the reaction kinetics, which is explained in terms of kinetics. You can see over the degradation also. So that is going to be there. The ultimate aim is that this is what the focus is going to be. Any material I am going to use it. What I am going to do that one? I am going to use it for a purpose. What is that one? And water purification. And expected water purification unit, which can run in a water or by using LED light, whatever it can be. Two things, option is given. When it is going to be run with a solar light, then the competency of the material is very, very important, so that nothing is going to happen over there. So we are going to come up, we are just almost in the process of fabricating a reactor. In the process, by using the GC3N4 as the material, we already quoted, which is having a 30 liter of capacity. The design is a little bit different from here because we are going for a patterning. So that's why I have not shown the design over here. So it is going in a different aspect. So then we are going to have a treatment unit, and then we are just drawing a daughter now, which is going to meet the BAE standard, WHO standard. Then whether this can be marketable or not, that is the secondary questions. We need to see the hurdles over there, because little bit we are all the bottlenecks, we are just moving, all the bottlenecks whatever we faced has complete, we are eliminated somehow, and then we reached almost 90% the destination alone. So now this destination, how far this is going to be successful after the treating over there and then reaching the people, only will come to know whether it goes. We are intent to develop this mainly for the rural background, because in rural background only people are struggling for the water because they don't know how to treat the water. Rural urban background, there is no issue over there. So this can easily actually can treat the water for them, at least, so that can keep them safe. You have a composite filter which is going to have an actually very simple, which is a 30 rupees or 40 rupees, which can be available even readily commercially, which is actually an 5 micron filter is readily available over there. Even in Amazon you can get it over there. It's very simple. We are going to construct with the locally available things very easily with the least cost. So our main part is the development of this two absorption unit. We are developing from them by using bamboo charcoal, and then the photovoltaic reactor we are developing with the things. The composite we are not focusing much. We are taking the commercial aspect only, because that is not our subject of study. So ultimately our aim is, this is what our aim, a community which have this kind of a 1,000 liter or 2,000 water liter. So this treatment will be supplied to all the household over there. Suppose you have a village is having a 30 houses, 40 houses. You can see in every villages will have an overhead water tank where they supply water from there, very simply. So similar kind of system where you have a reactor over there. So that reactor is going to help you over there, and that's what. So that is what we are moving into that aspect as much as possibly in a large scale applications. So I want to thank my team members contributed from 2010. Since 2010, which in Malaysia, we had 6 or 7 members from the 7, I think 6 members from there who contributed for the things. And then my 7 members who are currently working, a few of them are currently, because we are graduated, for their contribution over there. And I also grateful to the Malaysian government, because they also heavily funded me at that point, actually, where I was doing enormous amount of work over there. And then I'm very grateful to, after returning back also, I got a good amount of money from the Indian in terms of ECR or in terms of imprint for to carry out my project, to commercialize the project or to protect.
Dr. Saravanan, Pichiah, it was a wonderful talk.
Yeah.
I'm from a very nice about this ternary, that combination silver vanadate, that combination, no? I just missed it. Is it a full spectrum thing?
No, silver is not full spectrum. So full
combination, that silver.
Yes, that is actually visible light only. Full spectrum is WS2, WO3, GC3N4. All are full spectrum. This WS2 combination is full spectrum. WO3 is combination full spectrum. But this AgBO3 or InBO3, they are all visible light only. And we have not studied in that aspect. I said, we studied in a different aspect. We just executed and water treatment application alone. But that is completely material study only.
Okay. Sure. Okay.
That's it.
That's interesting combination.
Yes. That's what we reported over there. How it is interesting, why it is interesting. That is what actually our objective of discussion over there.
So is there any heterostructure interface between these material, like how they have combined?
Yes. We come to know the junction formation, the PN junction formations. What is the junction formation between them? How they interact between them? How the interaction is taking place, how this interaction is very good for other aspects like time, the decay time. So switching, the photo switching properties. We have seen the photo switching properties. These are all quite very highlighting things over there in that AGB.
Okay, great. Thank you so much.
Thank you, Professor Villupuram, for this clarification. So any other participants, please?
What about manganese oxide they combine? Manganese oxide, I have not tried. What about manganese oxide? Okay, when it comes into the point of water treatment or water purification, as I said, as a materials, we can try any materials. There is no harm in that. It works well. When it works well, when you understand the science behind this one, material chemistry, you can switch it over the application directly to water split, or you can use it for CO2 reduction also. In CO2 reduction or methane oxidation, if it works well, or solar fuel, that this is not an issue, which means toxicity is not an issue. because you need to drive this reaction, and then you want to get the products, like you want to get a methane, or you want to get a formaldehyde, or you want to get a hydrogen. It doesn't fact over that. But when it comes to our water, the water means it is again a problem. It is going to be intake by the human. When you want to take intake, it should not have ensure any foreign materials present over that. Very important. That is the reason why most of the companies going for membrane, because membrane ensures separation. So it is giving you only pure water. So they are safe in the aspect of technology point of view. But that is not a good solution. So this is what the problem over here. So for that only we are coming with the reverse process. So manganese also we can try it. It's not an issue. But how far this manganese toxicity, so that will impact toxicity water, solubility is factors, other factors, whether it can be immobilized, because we want to make a coating over that, whether it is hydrophobic, hydrophilic, it can stick to that one, it can interact with the water. Those aspects are very crucial whenever we study for that, when it goes for a treatment aspects. Self-cleaning aspect, any self-cleaning material, these are all very important.
Yeah, is there any question? So another one more thing in addition to the Professor Saravanan, this manganese oxide keep on changing its oxidation state. It's not a stable one.
Okay, that
and
is
moreover,
yes,
in addition to that, but it can be used to assist the other material to enhance the photochemical reaction. Sometimes people used to do that. So yeah. So any other question, please? Yeah, thank you, Professor Saravanan. So I have two clarification. The one is that how do you purify that degraded product from the water? Because that itself takes so much of study, and that is more toxic than normal for purified water.
Generally, after
so
the
do you have
treatment,
any idea about that?
Okay, I will let you know. I will let you know. Very simply, I will let you know. So what we used to do actually, we actually coat the material on a slide. Okay, I'm just explaining what we are doing it. We coat, suppose GC3N4 easily prepared, coating over that on the slide. Coating we are using actually in local and material coating and adhesion. This adhesion also is an organic compound that should not be get leached over that. Suppose you take a P dot, for example, P dot, it can also used as an adhesive material. Suppose you are using over that, and if you are coating over that, and the coating is going to be water stable, fine. But we dip in the water throughout the studies we will carry out. For continuously we carry out photo daily regular 1 day, 2 day, 3 day, 30 days, water stability, water leaching. All the collected samples are sent for the LCMS analysis, and we want to see how much of the concentration of the leachate is present over there. If that is treated, for example, we take in a small flask, 100 ml beaker, once it is treated, after treatment, what is the fractions left over there in GCMS? What are the carbon fraction left over there? All are completely studied over there. We are intent to have only things, but we are not focusing one thing here, the heavy metals. I'm just telling, heavy metals means metals, we are not focusing on that, assuming that no harming heavy metals. But though heavy metals also present over there, we are just giving an absorption cartridge, and we are giving an filtration cartridge. So suspended particle also going to get filtered over there, and then second stage you will get that absorption. If a lower level concentration of this is going to be also that is also going to be removed. We have carried out absorption studies by using the bamboo charcoal for everything, for organic compound, for inorganic compound, and for mixture of organic inorganic compound. All the trial test has been studied for 2 to 3 months, and we have found it is having excellent in removing the compound in a lower concentration. Also this can be removed. For example, as the chairman has read, in untreated compound is coming over there, water is not completely treatment, full intermediates are present over there, so that will go over there, that will be absorbed completely in that absorption column. So security wise, that's what we are giving a safety point we are giving over there. So now the thing is that whether you need to have a 1 column or 2 column, that studies we are going over there. So if that is going to be 1 column of 30 centimeter or 40 centimeters is more than enough column height, then that is going to, what we have seen now, 30 to 40 centimeter column is more than good in order to remove all those things. Your water is completely keep up. It can filter close to 2000 to 2500 liters of water, then bed gets saturated. When we have to replace with that. So for your filter, that is suspended solids is not needed, because that is based on the suspended solids level, but absorption has to be has been replaced with a new column. That's it.
Okay. Did you come up with anything so that if I use this kind of column, so we can remove this much percentage of the degraded compounds? Or
yes. We have
did you come up with anything? Because
yes, some of the studies we carried out, and since we don't want to repeat most of the studies on absorptions are available in literatures, no, many are available. We have studied only selectively which is needed for this scale-up purpose alone. What is needed for the scale-up purpose, that has been experimented.
Okay, then it's great. Especially if you work on especially 2,4 this dichlorobenzene itself, it's a great effort. Chlorophenol, that itself is a
Yes,
great
yes, yes,
effort
yes,
only.
yes.
Yeah. So okay, one more question. It's not only you, because here so many eminent professors are here from a very good institute in India, across the institute from India. What about the cleaning of the river of the water in river of Ganga? So this finding could possible to achieve to clean the water in a river in Ganga river, especially towards the Kasi and Varanasi. Always I used to see from a childhood, is always water is not in watercolor. It's always some dark color or something like.
Okay.
Yeah.
I see in that point of view, we cannot say nothing is possible because we need to try out only then. So what I can suggest is this photocatalyst material itself can be made out of like a ball, and then we coat over the ball and then allow the ball to float over there. Surely it is going to give you some result. We cannot say zero result, because mostly when you go for actually this oil spillage, when you go for oil spillage purposes, many Chinese researchers or American researchers has developed a ball kind of thing, sponge kind of things, which can take up the recovery, oil recovery. If you see, the sponge is having a very high level rate of taking the oil recovery. They studied throughout 5 to 10 years. The same concept we can apply it for here. When you go with this kind of balls floating over there, or we can have a fishnet kind of arrangement floating, under which you can hang the balls and submerge to the depth of the river. So whatever it is going over there, because whenever the river is there, it will have an visibility. Sunlight can penetrate to 1 or at least 200 to 300 meters to 400 meters. Sunlight can penetrate. It will never have any problem. If you are having two turbid only, the penetration of sunlight will have the problems. When you see in the limenology, in the aspect of limenology will come over there. So light can pass through it. When light is passed through, the diffuse sunlight itself can work over there. For that, it can do some of the things. So the top level.
The problem with that, the passage of light, that is some limitation. But we can develop it like absorption process, am I right? Based on the absorption.
We can combine the process. We can combine the process. Combine the process. Not single is not possible. We need to come up with different combine the process.
Okay. So if dear participants, if you don't have any questions, I can close this session with Saravanan for his wonderful talk and to learn so many things, how to develop the material especially. So he has worked vast of material, lot of good material is there, and so to do great, it's a very good for the water remediation is one of the challenging tasks in India. We have to come up some great material. So again, I thank you very much for Saravanan for giving this wonderful lecture. Thank you very much, and also I thank you for organizer for providing this opportunity. Thank you.
Thanks.
Yes, sir. Thank you for
thank you, Chairman.
Experts, sir.
Thank you,
sir. Saravanan, sir. Special thank for you, sir.
So I should thank Rajkumar, and special thanks to Murudas because he is my close friend. So he is taking as a chair in a session is I'm happy to present when he takes over the chair session.
Yeah, me too. I'm very pleasure
very lovable time for him.
Yeah. Rajkumar, thank you for opportunity.
Yes,
okay.
Yes.
Thank you, sir, for enlightening presentation. Tiny seeds make boundless harvest. Drops of rain compose the showers. Seconds make the flying minutes, and minutes make the hours.